The diagram shows a trapezium FGHI with FG parallel to IH, GH and FI both have length 2. The point M is the midpoint of FI and angle HMG is 90 degrees. What is the length of the perimeter of the trapezium? So what I did is I extend HI to H dashed. So if I say extend HI to H dashed and GF to G dashed, and then I join H dash G dash. Then what I am going to do is, what you see happens as a result of that is HH dash is parallel to HH dash is parallel to GG dash. That's because HI is parallel to FG, and so therefore, being just extensions of the same line, HH dash would be parallel to GG dashed. Okay, so then what we are going to do is I'm going to name them. So HM I'm going to call A, and MG is B, and HG is 2, IM is 1 and 1, and HI is C, and FG is D. So then what I'm going to write that. So HM equals A. So let HM is A, and MG is B, and then HI is C, and GF is D. And then I'm going to say that triangle HIM is congruent to triangle FMG dashed, and that is because IM equals MF, and we have angle MFG dashed, that's this angle, would equal angle MIH, angle MFG dashed equals angle MIH. They are alternate angles. And next I'm going to say, with similar reasoning, that angle FG dashed M equals angle MH, that's equals MHI. So this triangle is congruent, these two triangles. Therefore, what I can conclude is that GM equals A and G dashed F equals C. So G dashed F is C, and then GM is A. So the next thing is applying similar logic to triangles H dashed IM and FMG. We can prove that they are congruent. So triangle H dash IM is congruent to triangle FMG. Once again, the reason is, so we can say this time that angle HMI is equal to angle CMG, angle HMI equals angle CMG, And of course IM is IF. And you will have angle IH-M equals angle MGF. And that would mean, so we've got two angles on one side, as we did in the other case. We've got these two angles, and we've got these two angles, and we've got the side. So we can prove, and it is proven, that these two triangles are congruent. Okay, and from this congruency, what we can say is, therefore, H'(I) equals D, and H'(M) equals B. So that's B. So we got that. Okay, so now you see what comes out of this is H'(G) and H'(G) are diagonals of H'(G) G', and we can find out very easily that these diagonals bisect each other at right angles. Okay, so now if you look at, we can say that angle H'(MG' is equal angle H'(MG' is also equal to 90 degrees, and that equals angle HMG. They are all opposite angles, vertically opposite angles. So I can say vertically opposite angles. Okay, and therefore what it comes out is that H'(HG' is a rhombus. Alternate sides are equal, CD. So all sides are equal, actually, rhombus, because what is happening is first of all, we start with, it's a parallelogram. So, and because the diagonals bisect each other, sorry, I think I should start there and then come to the fact that it's a rhombus. And since the diagonals H'(G) and HG' bisect each other at right angles, okay, therefore H'(HG' is a rhombus. Okay, so once we know that, so what happens is the sides are equal, therefore C plus D equals 2. That is what we wanted to find out. So therefore C plus D equals 2. And once we know that, we can then find the perimeter of the trapezium. That's the final thing. That's what we want to get to. So we can say the perimeter of the trapezium equals 2 plus 2 plus C plus D, which is 2, and that equals 6. So that is the length of the perimeter of the trapezium.